Well, I'm back from what I consider to be a well-deserved little holiday. And all the time I was there, I was thinking about this guy. And someone made a comment about feeling sorry for me because I keep looking at this enclosure, only afterwards realizing I have to open it up. Well, I've got to tell you, when it comes to FM front ends, I do tend to procrastinate quite a bit because I've been inside these things before. Very often things work out. A few times it didn't. When it doesn't work out, it's not fun. So the first thing I did was I desoldered everything. This is the 10.7 megahertz signal coming out here. There's a resistor and a capacitor there. That corresponds perfectly with the service manual. And even the pins are numbered correctly. If you start on the other side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you follow the order, and that's exactly what I found there. So that side is now free. And then I did the same to this side. I took everything out that will stop the shield from coming off. These components are actually soldered to a little tab there that's connected to the shield, so that should come off quite easily. But before I carry on, I want to thank the sponsors of this video, PCBWay. You'll find them at PCBWay.com. They're the people I go to for all the PCBs that I use on my projects, and I find that ordering PCBs from them is really, really simple. It's all basically automated. You put in your Gerber files, the quantity, the type, and so on, and it gives you a quote, and then you can order directly from there. Now, if you're trying to prototype a project, there's a lot of stuff you can do with them. You can order all sorts of PCB types depending on your needs, whether they're standard, advanced, rigid, flex, and so on. You can get them to actually assemble these things for you. And if you want to take your project to the next level, there's also CNC machining, 3D printing, sheet metal fabrication, and all these services that probably satisfy and far exceed any needs you may have. Next time you want to order a PCB, whether it's from one of the projects that I suggest or your own or any of the others you find on the share section of the PCBWay website, go to PCBWay. I'm sure you'll find something for your needs. Just to be safe, I did create a little sketch of exactly what I'm taking out of there. I take some photos, and obviously the videos that I'm recording now also help, but I do like to do this. It takes all the guessing out of it. So now I've got to see what screws I need to remove. I know there are a couple on this side. There's one there, one there, one there. Some of these you don't even have to actually remove them. You just loosen them and they slide out. I've got to remove the shield and the tube. And I think there are a few more down here. There's a hole in the shield, so I think this, well, I know that this can stay in place. There might be some underneath. I'll have to check that out. I'll remove those screws and then show you what we are facing. Well, that idea is not going to work. If I remove the shield, I need to get access to the bottom. There's some screws there. So what I'm going to have to do is remove this entire bracket, which is held on the underside with 2 screws, and then this whole thing connects to it. Then I will have access to the other side of this, and I'll be able to take the shield out. So I'm going to have to remove the 2 screws on the bottom side. I will have to remove this. I've turned this fully clockwise, so it's at the end. In this position, I believe I've got access to the screws that hold this onto the shaft. There's one there and one there. I can get to that, unscrew that, pull this off the shaft. I'm going to put some tape around here. Hopefully this won't all come unwound, and I'll be able to pull this forward and then remove this whole thing. Step 1 is done. I've managed to remove that from there, and I think it's going to stay wound. We'll see. Now on the underside, if I'm not mistaken, it's this screw and that one, which I'll have to unscrew, and it's going to loosen the caps, so I'll have to put that back later. And here we are. It was just those screws at the bottom, and you see there are those screws there that I would have to get to be able to remove this shield. It looks like I'm going to have to remove this bracket as well. So 1, 2, 3 screws, this bracket comes out, and then these can be loosened and the shield should come out. Let's see if that works out as we planned. Okay, that is out of there. Now I've loosened that. I think I've loosened that. Yes, that's loose. This one, I think, yeah, that one's loose. I've got to loosen that guy. And that guy. And this should just pop out. Here is the heart of this thing. Not much to it, is there? We've got our tuning condenser with two gangs, one for the oscillator, one for the RF. And I can actually add a little bit more lubrication. It's quite smooth, but you can always improve on it. It's fairly compact, and there are components sort of stuck to the side of the coil. You've got to be very, very careful. Now, I believe I've got to find the front end coils and trimmers. I believe that's one there, one there. I'm not sure whether that's the oscillator or the front end, the RF, but I can follow the lines from here and ohm them out. Make sure that I get the right one, and I think it'll be something to do with this trimmer, either this one or that one. That's what everybody seems to say is an issue, but I can also test the other components. Oh, there's another one on the underside here as well. Is that a cobweb or a wire? It's a cobweb. Okay. And let's see. No other mysteries here. Let me do some sniffing around. Maybe one of these trimmers is shorted, or there's a solder connection broken, or something. I'll find out. This is now just a question of going to the, this is a bit of glue, going to the schematic and ohming everything out. Make sure you get continuity where it's supposed to be and not get continuity where it's not supposed to be. Now you see all these little things here. This is a capacitor here. There's another small cap. There's a resistor. I'll have to wash this first, I think, with isopropyl alcohol. Check those resistor values. This trimmer could also be the problem. This is strange because they tell you that one of the adjustments that you make, on the side is this guy over here, but how do you adjust this trimmer? That can only be done from the bottom side. Is there a hole on the bottom side? Oh yeah, there is. Okay. Yeah, you can get through the bottom and adjust that trim. I think I did that as well. Let me get cracking and I'll report back on any mysterious findings or solutions. All right, folks, let me show you what I have done. Quite a bit has been achieved here. Quite a lot and very little. That might sound cryptic, but that's exactly what happened. I did a full cleanup of this with the airbrush using isopropyl alcohol, and then I did some checking of components. They all seem to be within spec. Some of the resistors are a little bit on the high side, but certainly still within spec. So I decided to do the following. I decided to put this all back together here in place. Oh, before doing that, I did go to that trimmer. I did desolder everything from one side of the trimmer. I tested the trimmer. The trimmer seems to be fine. At least now, after the cleaning, the trimmer seems to be fine. I did think that perhaps the cleaning had something to do with it, but I can't prove one way or the other. So I've connected everything up like this, and I know that I can adjust it like this, but I do know that once I have the shield on, I have to realign it. But let me show you what we can achieve like this. We can actually see the oscillator working, and we can see the frequency on the oscillator. And all you need to do for that is literally create a little loop on your oscilloscope probe. So I connect the ground to there. I've got a little loop, and now I can wander it around, wave it around, and see what happens on the scope when I switch this on. Let me switch it on for you, and I'll show you what we can achieve here. So the first thing we see is we can actually tune it. It's probably got a little bit more noise than it should have because there's no shield on it. But More importantly, let me put the sound down and show you what we can probe on here to see on the scope. Okay, we can see very little on the scope right now, but if I start moving this closer, look what happens. We definitely are picking something up. And the thing to do is go to where you pick it up the best, which seems to be like here. Let's see, where was I? There. In fact, what you can do is use a bit of tape and keep it in place. That's always a lot easier to work with. Let me see if I lean it. I don't want to touch anything. I just want to be probing. I don't want to load the circuit down at all with the actual probe. So I'm just going to do this. Okay. Now watch this. If I go to, let's see, we are seeing, what frequency are we seeing? We're seeing 99.4. What we're seeing is the oscillator frequency. And to prove that, I'm going to show you, if I go up, the frequency is going to 112 let's say 112.4. 112.4 megahertz. Now, if you take 10.7 from that, 112.4 minus 10.7 is 102.4, 101.7. I did that on purpose now because I wanted to get that 101.6 on my band. Since I've got the freedom to play around with this, I might as well get it to a useful range. And if I go to the bottom end, it's giving me 97.3. Now that means it's giving me 87 megahertz. It's a little bit below the 87.5. That's the minimum on this. But let me tell you what I've done. I did adjust the bottom trimmer cap, which you're supposed to do at that end, and or rather at the other end. And what happens is that when you adjust that, it's very tight. So getting through this little hole at the bottom is a bit of a challenge. So I went in little steps, one step at a time. And we can see that if I take this now and play with the trim at the top, with the coil, you can see me change the frequency. It just goes a bit crazy. But what I want is that's too high, 97 point. It was about there, 97.9. If I go to the top now, what frequency do I have? I can actually make an adjustment here and get a bit of a change there as well, you see. But that's not really the right one to do. You're supposed to adjust the trimmer cap for the high frequency. But I want to make sure I get my 101.6 very clearly. So I'm going to trim past it. There, I know that I'm getting it all. I'm getting 102 megahertz there, so I can tune down to 101.6. There's 101.6. Let's go back to the other end. I'm on 98.06, so 88, 87.3. This is as close as it's going to get. But the thing to mention here is that this question of finding out whether your oscillator is working and the effects on the oscillator, instead of trying to adjust what you're seeing on the front there, you can actually do it here. And you can get this in various spots over here. One of the spots, like this one here, is obviously clearer. If I do that, I'm just getting the wire going through. So it's always best to find the angle that gets you the better result. And it does affect the coupling. It does affect the tank circuit because it is effectively coupling. And if it's coupling, it's going to have an effect. But it is, oh, there's a better one even. There, see that? And you can just read the frequency on the scope. So I'm going to forget the readings on the dial, and really I can adjust the position of the pointer by shifting it on the dial. But this was more important for me. At one point I thought perhaps the tube was weak, so I I replaced it with a new old stock ECC 85, and I found it made no difference, which means the tube is fine. But I've done this a few times before. I found that this is the easiest way to check the oscillator and the adjustment of the oscillator. The one thing that is annoying, as I've mentioned, is that this trimmer cap for the high frequency adjustment is on the bottom, and you literally have to put your screwdriver through the bottom up to the trimmer, and it's not perfectly aligned. It's slightly off, and maybe that's what happens. People put the trimmers in there and they put too much force sideways. That might have been the problem, might have shifted something. I did touch up the solder connections because there might have been a cold solder joint, but I've seen these things jump around everywhere. I've seen oscillators go from, you're trimming down, 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 or you're trimming up, for example, and at a certain point it goes from, picking up 101, 102 to suddenly reverting back, because what happens is that you start getting a flip back on the IF, and actually it happens more at the bottom. It flips back and it picks up a higher frequency. It can go anywhere. It goes crazy. So yeah, that's what I've done. And now what I'm going to do is I can just slide this in. I can slide it in there. Obviously I have to desolder these guys. Slide it in, screw it to that chassis. I don't need to screw the bottom ones. It's not a big deal. But as long as I've got the side ones and the top ones tightened, the shield will do its job. And then I got to do a little realignment again, because this will affect the actual alignment. I have not adjusted the peaking of the RF. I want to do that as well. Okay, let me put this together and we'll try peak the RF. Right, the lid's back on, the shield's back on. I've screwed the shield to that panel there with 2, 4, 6 screws. So 1, 2, 3, 4, 5, 6. 2 on the underside have gone unscrewed. Everything has been nicely soldered back on here. I did check again with the little sketch that I'd done. Not an issue. So what have we got? Well, at the bottom end, let me put this to 88. I'm going to put this to 88. So I'm going to be sending a signal at 88. Actually, there's a station there. That could be difficult. Let's see what we get, where we get that 88. Slap bang on top of a station, and I'm getting 88. Well, let's try a little bit lower. 87.5. Right, 87.5. Where do we pick that up? Right down here. And I can't really read that. I mean, this is how bad this is. 87. 88.5, 88, 87. It's reading 87.5 at 87. Okay, now top end, I'm going to go to, actually let me put 98 on here. See where it is we pick up 98. If I can even read the frequency on that line there on the screen. It's about a 97 or so. Now 101.6 is easy, because all I do is I go to my favorite station up here. There's my station, and it is showing at 100, well, really at 100. So I've achieved what I want to achieve. What I want to do quickly is just to see if I can improve reception, improve the sensitivity. And they do tell us how to do that, but it's actually quite strange, because they literally tell us to set it or tune it to 90 and then adjust that guy there, which is M, for the highest amount of noise. You don't even put a signal on there, you just listen for noise. And then you tune it to 99.6 and you adjust that trimmer for the greatest amount of noise. So let's do that. Now, because my dial is not accurate, I'm putting a signal here at 90 megahertz, and I'm going to see where that is. There's 90. Switch off the generator. Just put this as loud, and now I'm going to adjust this and try and make that all that static as loud as possible. That really is not very scientific. You know what? I can't hear any difference. I cannot hear any difference. Strange. Let's go to 99.6, which is somewhere up here. There's one at 99 that I know. That's 99. Sorry, that is 99. That'll be about 99.6. Now again, trim for the greatest amount of static, which is always rather subjective, but we'll give it a try. Oh, there I can hear it. That worked. That's the greatest amount of static, so it seems that my RF alignment is done. That is rather strange. What I could have done is I could have sent a signal at, 90, and then measured the amplitude on the speaker and peaked it for amplitude. As you saw, very little change. The one at 99.6, I could have done the same. What they say is do it by ear. And a lot of these old radios did tell you to do it by ear. And I guess a lot of technicians just got so used to it, probably did a better job by ear than most of the equipment could do. So that is it, folks. It seems that the FM nightmare is not that much of a nightmare. It's just something that I'm very reluctant to do. And I've had a few mishaps. Fortunately, it happened on radios that I had different or replacement front ends for. On one occasion, I broke part of the shield and it was shorting all sort of stuff inside. You've got to be very careful. It's not as dramatic as perhaps some of you may have read or interpreted from my warnings, but it is something that I do try to avoid. And I'm actually quite happy that I did go into this one because I've enjoyed it and got the result that I wanted. So that is where I'm going to leave you for now, folks. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Once again, thanks for watching. Bye for now. And most of all, stay sane.